Cool. Morning, everyone. Ooh. Hopefully that'll settle down. Who here is using React? Not many. That's good. What I want to talk to you today about is let you know what's coming in the new version of React. So there's this thing that's been talked about in the React community for probably over a year, maybe coming up to a year and a half, 2 years, called React Fibre. It's been a long time in the making, and there's a heap of excitement around the React community. By the end of this session, you'll know what it is, and hopefully you're a bit excited about what Fibre is and how React has actually reapproached the way we build single-page web applications and the reasons it looks the way it does. So my name's Jake. I work over in Perth at 7 West Media. Specifically, I work under WA News, so I help build the west.com.au. It's going to get annoying. Oh well. Suggestions? We'll see if we can settle it down over the next few minutes. So I help build the west.com.au, which is a news website. We started this project just about a year ago, and WA News actually didn't have any of their own tech. All of their tech was previously outsourced, so we started a team, and we decided to use React to build the news platform. It's been a very interesting year. We've built a news site from scratch, integrated with the print CMS, and we use React with server-side rendering, so really new technologies. So I got involved with React kind of a couple of years ago in London doing financial trading systems. Previously, I was doing WPF and MVC and a mixture of other things. And React was been one of the first technologies for quite a while that just got me really excited. And a year in, I'm still loving it. So this quote describes quite well one of the rationale behind React. So Dijkstra says, our intellectual powers are rather geared towards master static relations rather than our ability to process things evolving in time. So what does that actually mean? Well, if we just simplify it back down, the reason we like server-side and request response traditional MVC apps is it's like ordering a beer. You just ask for a beer and then you get it. And then you ask for another one and you get it. It's stateless. You don't have to worry about things changing over time. Single-page applications tend to be more like this, where as things change over time, you get all this state that builds up in your DOM, and it sort of evolves over time, and it becomes really hard to rationalize. So at Facebook, they're really struggling with this. React is a framework built and supported by Facebook, and it was a homegrown solution to this problem. They just found that their apps were getting, or website was just getting really, really complicated, especially on the admin side of things. So they wanted to just try and change the paradigm that they were using to build web applications. It actually took inspiration from a couple of different things, but one of them is the way games actually work. So games have a game loop. What they do is they process input, update the state of the game, and then they re-render. It's too expensive to try and figure out how to change what's rendered on the screen, so they just re-render at 60 frames a second. React actually takes that and is like, how can we apply the same model to our single-page applications where I've got my application state and I just want to re-render it? We already had that with handlebars, right? Who's used handlebars before? Cool. Old school templating JavaScript library. You use string interpolation, essentially, and you pass it some state, and you get a DOM out the other side, or some rendered text. So they started off by reinventing the wheel, essentially. But there are a few reasons why handlebars doesn't work for any sort of reasonable application. Every time you reevaluate that template, you destroy the whole DOM and then recreate it. So you lose any sort of focus or scroll position, all of that sort of stuff. It's also, the DOM is really expensive to interact with. Templates also are not standard syntax. So each time you go to a different templating library, they have a different way of doing string interpolation or binding to things, different way of doing loops and conditionals. And every time you want to have some sort of extra logic in your templates, you have to invent a new way of solving that problem. So for a number of reasons, we don't want to go down templates. Libraries like Angular and Knockout.js took this a step further, where you created your model and you've got your template and then you bind between the two. So when your model changes, you can update bits in the DOM. Kind of gives you the best of both worlds. Still quite hard to reason about what's happening in your application. So when they were rebuilding React, they came up with a few design principles that they wanted to anchor React on. The first one is composition. We all know sort of the recommendations around we prefer composition over inheritance. That's a good way to build an app that's easy to sort of scale and reason about. So composition in React had to be first class. We wanted to be able to just build using components, bring them together easily, be able to refactor, and just build our application up from all of these little parts. They wanted a common abstraction as well. So they didn't want to include everything in the library, because then you don't let the community figure out the best ways, what are the best patterns to do, and let things evolve over time. But they also didn't want to include nothing in React, because when you've got a library and everyone's building applications, if we have 3 ways of doing state management, the lowest common denominator for React is what comes in. So all of these different libraries, if they say you've got different ways of passing information through different components, if React didn't specify how to do that, you just would have a lot of divergence in the community and that sort of stuff. So they wanted to include a minimal amount of features in there, but enough that it was powerful and gave you a really good base. To extend that, they also wanted to make sure we had escape hatches. So rather than being an all-encompassing framework that has solves all of these problems, as soon as you hit a limitation of React, how can you get out and do it the way you've always done it? So make sure there's these easy escape hatches so we don't run into these limitations. Facebook currently have over 20,000 React components. So every time they make changes to the library, that's going to hurt them. So stability was, in terms of API, was super important. They needed to be able to let React evolve over time and get better, but not constantly be spending all of their time refactoring all of these components. So make sure it's stable, but the library can also evolve. Interoperability. Make sure it can work with the existing community. We don't want to create a separate ecosystem that can't interop with the rest of the web. Scheduling. This one is one of the most important things when it comes to Fibre. The API for React they want the library to be able to make good decisions on when things should happen. So you'll notice in data binding sort of paradigms, if you're getting a lot of updates, your application slows down. And it's up to you to stop all of these updates happening so you don't kill the performance of your application. React's API has been designed to invert that. You should be able to tell React what you want to do and not have to try and throttle things yourself. So scheduling was first class. The library should be scheduling when work happens, because it can make better decisions, hopefully, than you can. So over time, the library can improve and get better, and your application just gets better with it. They have a lot of developers at Facebook, right? So developer experience was super important. We don't want cryptic error messages. We want to be able to debug it easily. We want to be able to point people in the right direction. So we've actually got our developers being productive and not wasting time on silly issues. So really nice. You'll notice when you start using React, when something goes wrong, or even if it's not going wrong, but you're using the wrong pattern, it'll be telling you, hey, you should be doing this. Click on this link to know why, that sort of thing. So it's constantly informing developers on how to do things better and detecting when you're doing bad things and encouraging you to fix them. And then debugging. So when something goes wrong with React, because it's all component orientated with really explicit data flows, super easy to sort of see at which point a component poisoned the tree, so to speak. So you can go in and see, oh, this component here has changed the data that's being passed down. So with all of that said, how does React actually work? We have a React component here. I've lost syntax highlighting for some reason. That's frustrating. I'm not sure how to fix this. Let's go. There we go. Can people read that? Not really. Let us. Interestingly enough, my slides are built in React as well. How's that? Everyone read that? Excellent. So at the top, we have an agenda React component. Who's seen a React component before? Cool, a lot of people. Excellent. So this is known as a stateful component, and we use ES6 syntax and extend React.component. The only requirement for a React component is it has a render function. And this tells React what this component actually wants to display on the screen. Because it's all JavaScript, we just return a representation of what we want rendered. So if my current state's loading, I want to return a div that says loading. We can also compose our different application components together. So if I was building the NDC schedule builder, we can have a schedule component. Consuming normal HTML DOM elements and custom components, exactly the same. Makes it really, really easy to extend over time. We can then pass what are called props to these custom components. So I'm passing down a list of talks that I've saved that I'm interested in, all of the talks at NDC, and you can also pass functions as props. So this add to schedule is just a callback. So when the schedule component wants to add something to the schedule, it just calls this prop. It then sets state. So when you extend React.component, that component is allowed to have state. The way we set state is using a function called setState. When we talked about the design principle around scheduling, this is a really key design decision. So I can call setState as many times as I want, and it's up to React when it actually takes that state and calls render. So you can change the different, you can hook in and say, okay, React, I'd like you to just render using set animation frame and just re-render my app at 60 frames a second, much like a game. It's probably not going to give you great performance doing that, but it's an option. So using setState, that can happen in all these different components, and React can then batch all of those together and do a single render pass. It's up to React how it actually performs that. Because that's asynchronous and it gives you no guarantees, this is one of the things that has allowed React to re-implement its core without breaking the public API. So I call add schedule, it calls setState. At some point, probably within a very, very short time, React will call render, which then allows me to go from a loading state and just render out what's happening. So very declarative, you have your state, and when you render, it's pretty much a pure function. State goes through a render process, I have my rendered application. Much the same as handlebars. This is called a stateless component. So it's just a JavaScript variable that is a function. Is everyone using ES6 TypeScript? Cool. So for those that haven't seen this, this is the fat arrow syntax. This is just a JavaScript function. It's called a pure component or a stateless component because it just takes props and then produces some markup. Quite simple. Finally, we have lifecycle components, so lifecycle methods. So here I can hook into component will mount. This happens when my React component is going to be mounted into the DOM, but it hasn't yet. There's other ones like component did mount that after my component's been mounted into the DOM, it lets me know. We can also have component will unmount. So the really explicit lifecycle methods in React make it really easy to reason about when things are coming in. I can subscribe to changes, when it's going to be destroyed. I can unsubscribe, that sort of thing. So in there, I'm executing an async method and then continuation. So I'm fetching the agenda. Then once I've got it, I'm setting state once again, which will cause the re-render. And that's React in a nutshell. Anyway, so let's get back to the original question. What's Fibre? So React has two things. It has the renderer on one side, and then it has the reconciler on the other. So when we return some JSX, which is the XML kind of thing within our render function, it creates what's called a virtual DOM. Now this is just an in-memory representation of what you want rendered. So I have a div that creates a div element. When React gets given that element, it will actually create a div in the real DOM. The thing that turns that object structure from just a JavaScript object that says, I want a div with some text in it, to actually putting it in the DOM, that's the role of the renderer. We have a DOM renderer. We also have like a DOM to string, or to string renderer, which you can use on the server. So rather than going document.createElement and actually building up a DOM, it can just render it to a string, much like in an MVC app or something like that. But that doesn't help us make changes over time. We're constantly re-rendering our app. And what the virtual DOM's responsibility is when you create a new virtual DOM, React will actually diff it with what the previous virtual DOM was. It'll then identify any changes that have happened between the previous render and the new renderer. It'll then create a patch which it'll apply to the real DOM. And that's one of the breakthroughs of React. So what Fibre is, firstly, is in React 15 and below, these two things were just part of React. They were tightly coupled. Things like React Native had to dive into the internals and override a bunch of internal stuff so it would actually work. React 16 and Fibre separates these two. So now there's an official documented renderer API, which makes it really, really easy to extend React so it can be rendered to other things. There's actually a huge amount of renderers now, and it's since React 16 has got released, or the beta, there's been a heap being created. So React Native, that allows us to use the same components right in JavaScript, except it projects, it renders out to a native component. So that could be Android, iOS, Windows 10 App Store. You've got all of these like opportunities there. We've got React VR, which allows us to use the same React components and actually render to a VR environment. React Canvas allows you to actually draw things with React. React PDF, you can render your components into a PDF document. There's also React Word for those sort of things. A novel one that I saw a couple of days ago is React FS, which allows you to render to a file system. So say you wanted to create a templating library, or like something like Yeoman that actually bootstrapped a project. You can create a representation of the files that you want using JSX, and then say render to file system, and it'll actually create all of these files and directory structures on disk. But the most novel one that I'm looking at the moment is we have a few designers, and they love Sketch. And there's always this problem of we've got a component library with all of these React components, and they've got this library of all of these Sketch components. And when we're building, we have to like measure and see what the margins are in Sketch. Nice people at Airbnb have been suffering from this, and they thought, well, we could use React to make this better. So their component library can render to a Sketch document. So as they make changes to all of their components that they're using to build the site, they're actually rendering these out to Sketch components and Sketch documents, which is a rapid prototyping design tool, which means things are always in sync. Pretty novel concept, and it allows you to render to the web or to Sketch or PDFs, and it's the same components. Pretty powerful concept. So Fibre was separating those two, and it's now super easy for you to actually write your own renderers. The other thing that, that Fibre is trying to solve is JavaScript in the browser and in Node has a single event loop. We can't get away from that. The world would break if we tried to make JavaScript multi-threaded. So this is going to be a limitation of the environment going forward. This causes quite a few problems over time. The current rendering model inside React, they call the stack renderer. And what happens is it starts at the top and recursively goes down through all of these components and renders them. What this is a triangle that has a whole lot of smaller triangles in it, and then smaller triangles again, and then finally has a bunch of circles in it with a number. So there's two types of animations going on here. There's one that is making the whole thing smaller and larger, and the other one is so that's happening sort of every 16 milliseconds or so. You want to have a nice smooth animation. But we've also, every second, we're incrementing the number that's in all of these little components. React is not great at handling this because you're changing everything and React can't optimize it. So it's trying to re-render that entire complex DOM tree and do a virtual DOM diff every 16 milliseconds, and it just can't keep up. So you're ending up with really long JavaScript frames, which blocks the UI thread, and you end up with jank. So when you start seeing your application getting really complicated with React, this can be a side effect that you're scrolling and you're janking because it's taking too long to do this render. The question was, is this React's implementation of tree shaking? So tree shaking in JavaScript land and Webpack is where I require a whole bunch of different modules, but there's more code in all of these modules that my application won't necessarily be using. What tree shaking allows like Webpack to do, for instance, is go through and statically analyze and see what hasn't been imported from your application and safely remove it. So it's similar to Uglify, which removes dead code, except uses the new JavaScript module syntax, which is the import and export, to be able to do it in a safe, statically analyzable way. So Fibre is more about the actual reconciliation process. So I've got my old virtual DOM, I've got the new virtual DOM. I need to be able to make changes to the actual DOM. How do I do that? Current implementation is top-down, synchronous. It just recursively bubbles down until it gets to the end, and then it applies the patch. Fibre is a complete re-implementation of React. It's pretty amazing. They've been working on it for ages, and they're just releasing React 16, and it's a drop-in replacement. They have upgraded it to all of their 20,000 odd components is running on this and has been for a little while. But what Fibre allows them to do is actually each of these components becomes a fibre or a unit of work, which allows them to start doing these render passes, and once they've used their elapsed time, give control back to the JavaScript event loop, and then ask to be scheduled again. They'll then do a bit more, and then go back. They also want to be able to cancel work. So when I'm doing this inside and outside animation, and these little guys are updating in there, I want to make sure that I'm actually dropping animation frames so I'm keeping up, rather than trying to try and do everything. So this is known as conflation. Like you're probably using it in your own applications whenever you've got a search box where you start typing and you're doing debouncing or throttling. That's a form of conflating the inputs so you don't ruin the your application experience. Because React's design principles, getting back to the scheduling one, you're just telling React that you have some state changes. Fibre allows, hopefully in the future, it's not enabled yet, but Fibre will allow React to make smart decisions about which updates are scheduled when. So just by applying Fibre with these new options, you see the previous one, you've got all of this jank. Turn Fibre asynchronous rendering on, much, much smoother. And the way it does that is each fibre can actually be assigned priorities. So remember we said we were trying to render every 16 milliseconds? Well, we want that to be given a really high priority. But updating all of these numbers across all of these, that's only happening once a second. It probably doesn't matter if it's 50 milliseconds later. So fibres can be assigned priority. So synchronous, which means it's done inline, synchronously. You can also say it's a task, which will mean it happens before the next tick. It's an animation. This fibre should be completed before the next animation frame. In terms of JavaScript, that's the difference between set timeout or set immediate and then request animation frame. You can then give it a high priority, low priority, or off screen. So React knows that it's in a, React DOM knows that it's in a browser. A browser has a viewport. What happens if Fibre could automatically assign a higher priority to components that are within the viewport rather than stuff that's out of the viewport? That's a possibility with Fibre. And that's why the community is so excited. At the moment, React 16 has come out. It's still using synchronous priorities for everything. They don't want to break the world. They want everyone running on the new version of Fibre to make sure that it's compatible and all of these React applications around the world can work without having to change anything. Hopefully, over the next year, we'll start seeing them turning on asynchronous rendering and a lot of these other prioritization, and people experimenting with what the possibilities are. This is really frustrating. since I've rebooted, all my colorings are gone. We support fragments in Fibre. What fragments are is, inside my render, I can now actually return an array with div key of 1 and div key of 2. One of the current limitations that drives my designers nuts is that you have to return a single element, which means you constantly, this component, I want to return 2 things, I have to wrap it in div. So one of the side effects of current React applications is you normally have a heap more divs than you actually require. React 16 supports fragments, which is returning an array instead. A lot of people are pretty happy about that. The next one is error boundaries. And what error boundaries are is now I can say component will catch. And when it's doing its render pass, this component essentially becomes a try-catch for all of the components under it. So if, for instance, you get down and there's some malformed data and a component's render function throws, it'll continue bubbling up until a component does this, which then I can go this.setState had error of true. Inside the render function, I can go this.state if this.state.had error. I can then render something that just goes, oops. So this allows you to gracefully handle errors. I know it's not to just continue bashing Angular, but when I was using Angular in anger, this was one of the things that was super frustrating. You'd have an error somewhere, and you'd just get a white screen, and it would take you forever to try and figure out what's actually gone wrong. Fibre, because it knows where in the render tree all of these units of work is, it can almost give you a stack trace between what components caused what errors. And that goes back to that developer experience. There's a site that I've been going to for, I think it got created in September last year, which is Fibre ready yet? This is a bit fuzzy, so you can't read it, but isfibrereadyyet.com. Finally, it's been saying no, and they've been graphing the pass rate of the unit tests within React. So slowly they got it quite close to completion, and then not quite. Obviously, they discovered some design problems, made some changes, which broke a heap of tests. And this has been going from red, yellow with warnings, slowly over to green. Finally, I think about a week or 2 ago, they got that all of the unit tests passing using the Fibre reconciliation engine. Then they released the beta. So this doesn't have the new scheduling engine turned on. It is still using the old synchronous flow, but so most applications should see a small performance improvement, but probably not a lot. Once the world is actually using the Fibre reconciliation engine and React 16, hopefully they'll start releasing the asynchronous rendering behind feature flags. So I wanted to leave a fair bit of time at the end. The workshop that I did on Monday and Tuesday, there was a heap of questions relating to the React ecosystem and how it fits in and where to go. So I'm going to open it up to the floor for questions. That's React Fibre. I hope it excites you. It's the potential for the JavaScript community to do some really cool stuff with this is amazing. So thank you. Any questions? The question is, can you use TypeScript with React Fibre? So all of our projects are written with TypeScript. React has a a concept called prop types. So you can actually say prop types equals and give it an object, and then define that my prop is a React.propType of object, for instance. That's the way you do type validation with React. If you want to use it with TypeScript, you can actually specify it becomes a generic component, and I can just say props and state. And then I can define an interface, which is props. And I can say my prop of type whatever. So React works very well with TypeScript, and Fibre actually did not. They made no breaking API changes over a complete rewrite of React. So your existing typings will work fine with Fibre. There will eventually be hints for prioritization and that sort of stuff, but that's not out yet. So the type definitions will be updated when that happens. You had a question?
Yep, so I'm mostly like a very Angular 4 heavy guy, so I do appreciate like the good things React offers.
Mm-hmm.
So the question mainly is, of late, if you actually study what these frameworks are doing, they're actually learning from each other. Like the thing around Airhead, like you mentioned, Angular has already learned that from React and implemented it, and likewise, Angular doesn't do two-way data binding anymore. It does one way, again, borrowed from React.
Yep.
So the question is, if a person or a company is willing to make the switch to React and especially React Fibre, what do you think? Do you think it's a good idea to switch frameworks? What are the advantages? For me personally, there's just one big advantage that React offers, which is the virtual DOM.
Mm-hmm.
So apart from that, what is important?
Yeah, so the question, I'll sum it down to something a bit smaller, which is essentially, if you're trying to pick frameworks, what would you consider essentially? Because all of these frameworks are learning from each other.
Doing the same thing.
Yeah. I think it comes down to what you want out of your library. Angular as a framework has a lot more. It has patterns around how to do data fetching. All of the testing patterns are defined. React has not done that. They wanted to create that lowest common abstraction and then let the community kind of define the patterns. So that's where you're seeing React change. Like the ecosystem is going through a lot of change, but that's outside of the library itself. The other nice thing is libraries like Preact, which are it's a small version of React essentially. It's an open source project that's mostly API compatible with React, except it's a 3K module instead of sort of 40 or 50, which I think React is. With libraries like that, if you've got like a complex grid that will benefit from the virtual DOM approach, you can actually mix and match. So you can create an Angular component which houses a React component. And that's the way that the migration path between Angular 1 and 2 works, is that you start creating Angular 2 components inside Angular 1 components and slowly take over. I think the most important thing is sort of understand your best practices and learn the fundamentals. One of the reasons I love React is it's all in on JavaScript. So you have to understand JavaScript, warts and all. Yeah, so like now Ember has picked up virtual DOM. There's a heap of virtual DOM libraries like Vue and whatnot. It's sort of spreading a fair amount. Any other questions? Daniel. Yep. So the question is around server-side rendering. There's a concept called universal rendering, which allows you to have your same JavaScript application run on the server as on the client. So if you go to thewest.com.au and you turn JavaScript off, you'll get a render of that page and you can click around and the site is functional. That's because we actually render the entire React app on the server as a string, ship it off to the client. The client JavaScript bundles then initialize, and our single-page application starts. The React reconciliation engine will notice that there is already a DOM there where it's going to mount. So it hydrates that into a virtual DOM. It does a client-side re-render, reconciles those, and then applies any updates to the real DOM. You're now then running in a single-page application mode where it has hooked into the event handlers. The second part of the question was, do you think that's worth it in terms of complexity? There's a lot of moving parts. It relies on Webpack to tell you what your assets are and a whole lot of extra work. You have to, on the server, you have to know once you're finished loading data. So you do an initial render, which is all in a loading state, load some data, do another render pass, which has all of their data, transfer that across to the client, and then start up your application. For us, it's critical because it removes a lot of the downsides of a single-page application in terms of the user gets a white screen until the JavaScript app has started and done that initial render. We also need really good SEO, so all of the bots can crawl it, and also if you post a link in Twitter or whatever, and it needs to get that little embedded card, that requires the server to return all of that information. So if your site is a content-driven site, then without a doubt, it is worth it. If you're building a single-page application, like a line of business application, or something that just has a login form before you can get into it, I wouldn't worry. The complexity is probably not worth it. Anything else?
The scheduling basis, they seem quite similar to Node.js, Angular. Have you? So I wasn't sure from the beginning how far you're involved in this, but have the people working mainly on this considered abstracting this as its own library, like its own thing, not just specific to React?
Yeah, so the question was, Angular has zones, which is a similar sort of concept. Would Facebook consider pulling the Fibre prioritization engine sort of out so it was consumable in other libraries? Honestly, I don't know. My background is I'm working and using this stuff day to day. I have a fair interest in it because we're buying into the technologies, and our team really believes in React and sort of the paradigms that it brings. So in short, I don't know. If you do want to learn more, there is a talk by Lynn Clark. If you search that, what is React Fibre? She's a developer at Firefox and focusing on sort of performance in their Gecko engine and whatnot. But she also has a Twitter account, which is Code Cartoons. So she turns all of these concepts into little code like animations and cartoons. If you want to dive deeper, she goes into React's reconciliation process at a lot deeper level than I did today. And it's really, really interesting, and she does a really good job of explaining things using cartoons and making it really easy to digest and understand. Lynn Clark. Any other questions? Yep.
I have a tiny bit. I wonder why this is TS, not TSX. I think that's why
So the reason the question is, why is this TS, not TSX, is because I wasn't supposed to be showing you code here. This was a module with a string inside it, which gets pulled into my slides. So I'm using a library called Spectacle, which allows me to specify a React library that allows me to build my slide decks using React, just because build everything in React, right? Anyone else?
Probably a very simple question. How long do you think before React or other frameworks become obsolete because of emerging things like web components, which will pretty much do what React and Angular do?
Interesting question. So the question was, when do you think all of these frameworks will become obsolete due to emerging technologies like web components? I would say in the case of React, they go hand in hand and are very complementary. So web components are an idea that you should be able to build your own custom HTML elements. So say you've got a HTML input that comes shipped in the browser. It's not just, it's actually a bunch of smaller primitives that has JavaScript, styles, and other HTML elements below it to make up that component, right? So web components have kind of existed in the browser for years. What that allows you to do is it uses a new thing that was shipped a while ago called the shadow DOM that essentially says, hey, browser, make all of the markup and JS and styles within this component invisible. So it just looks like a custom HTML element and all of that stuff goes away. So you can actually consume web components inside your React components, and they solve a different problem. React is all about the mental model of how you treat state in your application and how you compose your application together. Web components are about creating reusable functionality that can sort of give you better primitives to build your applications on. So they kind of have two sides of the thing and they work quite well together. Cool. Thanks, everyone. I will be around for the rest of the conference, probably hanging out in the GitHub booth or the Track.js booth. Come find me. And also, if you don't know about PubConf, it's on Friday. It is a great event that I'll be speaking at. If you come find me and ask a good question, I have and are interested to go, I have a free ticket. So come find me, and if you're interested, and you can go. So these are all fun talks that aren't recorded. It's at a pub. There's free beer. It's a great event. I highly recommend attending. So that's Friday evening. Thanks all.